Hello, 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 hello. Good people, I hope you had a good time. Let me start by first saying happy Valentine's Day, Joe Scientist. Today we are going to dive into something that is really interesting, known as the sedimentary fascists. So sediments tell a story of their past that is shaped by their environment, influenced by changing conditions, and leaving behind the clues for us to interpret. So whether it's a river caving its path, or a shoreline shifting, the tides, or or deep sea deposits forming over time, every fascist would reveal a unique chapter of Earth history. So grab your geological hat and let's explore the beauty of sedimentary fascists. Not only sedimentary fascists, but also the sedimentary codes and also the fascist analysis. But before you know what I'm gonna say, please don't forget to like, share, comment, and smash the notification button below so that you get notified once we upload new content. So, um, basically, sedimentary fascists, it's a distinct body of a rock or sediment with specific characteristics such as grain sizes, composition of fossils, and this would reflect the environment where it was deposited. Okay, so um, for example, imagine you're walking from a beach into an ocean, and then the sand beneath your feet slowly turns into something like muddy seafloor, and then even deeper, it becomes fine clay. So this gradual change in sediment type is what geologists call a sedimentary fascies. So different layers of sediment that tell us about their past environments. So the sedimentary fascists, they are very important to reconstruct their past environments and then finding natural resources and tracking the environmental changes. And if you haven't yet visited our video on the depositional environments, you are more than welcome to do so. And you are going to understand better how they are used to reconstruct past environments and also finding the oil and gases and the aquifers, and also tracking the environmental changes. So the types of sedimentary fascists are divided into the lithofascists, they're divided into the lithofascists, the biofascists, and also the ignofascists. Ignofascists are just trace fossils, whereas the biofascists are just fossil based, and then lithofascists that are just rock based. So the lithofascists, the word litho, it means rocks. So we're gonna be checking at the texture of those rocks that is to say, we are going to be looking at the grain sizes, the shape, the color, and the layering of those rocks. Okay, for example, we're going to be looking at, let's say, for example, cross-bedded sandstone fascists, which would suggest the ancient desert dune or just a river. And then the fossil based, this would be defined by fossil found in that particular sediment. Okay, let's say a rock layer with coral fossils, which would suggest a once shallow tropical sea, or you can have maybe, let's say, a rock with trilobites. Okay, then ignofascists, these are the trace fossils, what will be left behind. Okay, the trace fossils are known as the fingerprints. Okay, so these are based on animal burrows, tracks, or trails left in the sediments. Example: deep sea sediments with worm burrows that would indicate a quiet ocean floor with little disturbance. So, these are what we call the sedimentary fascists. Then now, we also, as a geologist, you need to understand what you call the fascist code. So, fascist code are a standardized way of describing and classifying sedimentary fascists based on their characteristics such as grain sizes, sedimentary structures, and depositional processes. These codes, they are very important. For example, that in the sense that when you are in South Africa, or whether you are in America or Australia or wherever, we need to describe our sedimentary rocks using the same standard, and these standards are these fascist codes. So you have to think of them like a shorthand system that would help geologists to quickly document and interpret different rock layers. Okay, why but do we have to use this fascist code? Okay, for consistency. Okay, we don't want to, have them a different perspective of how we interpret rocks. We don't want to say in South Africa we interpret them this way. In Switzerland we interpret them in this way. No, we don't want that. We want a standardized way of interpreting the rocks. The same way globally, and then also for efficiency, making it quicker to record detailed sedimentary descriptions, and then also this would help us to link sediment layers to specific depositional environment. All right, so the what you call the Mills fluvial fascist code. Okay, this is good for what you call for river deposits. Okay, the guy Andrew Mill developed a system to classify a fluvial deposit using letters to describe the grain sizes, the sedimentary structures, and the bedding. Okay. For example, the massive gravel, the planar cross-bedded sand, the massive mudstone, then this massive gravel will be GM, and then planar cross-bedded sand will be SP. Okay, and then FM for massive mud stone. Okay, so these are the common codes that are used when we are classifying the river deposits. Okay, and then we also have got the tubidite fascist code, known as the Boma sequence. So tubidites are deep-seated deposit formed by underwater landslides, and then the Boma sequence describes these deposits with fascists labeled from TA all the way to E. TA, TB, TC, TD, TE. Okay, where in TA is just a coarse graded sand. Then TB is parallel laminated sand, TC is a ripple laminated sand and silt, TD fine mud, TE is just a deep sea clay wherein the water is very quiet and we're gonna deposit these very fine sediments. Okay, this Boma sequence would help geologists to interpret ancient underwater landslides and sediment transport. And then we've got the fascists are associated or confined with the glacial deposits. So glacial deposits have their own classification. Okay. We have got massive diamictite, DMM. We've got stratified gravel, SG. We've got laminated clay, FH. And then basically these are the codes associated with glacial deposits. Then we also deal with what you call the fascist analysis. So fascist analysis in the sedimentary study or in sedimentary rocks, it's very important to help us to understand the rocks' origin, their depositional environment, and their geological history. So it will help reconstruct ancient landscape, whether a rock was once a part of a river, a desert, or a deep ocean. Okay. So if you want to understand this fascist analysis, you have to at least think of a beach to deep sea transition. Okay, let me give you an example. If you were to imagine a coastline where sea level rise over time, and then the fascist analysis might show something like what you call the beach fascist with sandstone ripple marks and shells. This would have been formed in shallow high energy waves. And then we can also have what you call the lagoon fascists, okay, where we have got mudstones, plant remains, and burrows. And then this would be expected where we've got the calm water behind the beach. And then we can also have deep sea fascists where we see the shales, the micro fossils, and thin layers. And then this would have the fine sediments settling in a still water. So basically this will tell geologists that the area was once a beach but was gone flooded by rising sea level. Okay, this is what we call the marine transgression. If you haven't also visited our videos on sedimentary fascists, you would see we have a video when we are talking about the transgressions and regressions. You are more than welcome to also visit that to see the sea coming in and out, and we're going to be having different different fascists. Okay, so this example of a beach to deep sea transition would have their respective fascists, as I've mentioned, would have beach fascists, lagoon fascists, and deep sea fascists. Okay. So a fascist analysis basically is like it's like you reading the diary. Okay, it would help you, or that diary, it will reveal much about where sediments came from, how they were deposited, and what Earth past environments looked like. Okay, so how does fascist analysis work? Okay, so the geologists examine rocks and sediments based on the grain sizes and composition and sedimentary structures, fossils, the color, how they look like, and the texture. Okay, how they feel like. Okay, so obviously if it's reddish colors it will indicate the iron. Okay, showing what you call oxic environment. And then fossils, what kind of fossils are those sediments containing, and then also sedimentary structures, as to whether we are having the ripple marks, as to whether we are having the the barrows, or the other sedimentary, or what you call them sedimentary structures. Yes, other we having the cross bedding. All right, yes. So, and also the grain sizes and composition, what is made up, whether it is made up of the sand, mud, or the gravel. Okay, so this is example of what you call the marine transgression. Transgression is when a shoreline is shifting towards the continent. Okay, and then when the shoreline is shifting towards the continent, you see that you're gonna see what you call the overlapping of sediments. Initially the beach would now become the deep sea, and then this marine transgression is defined by what you call the fining upwards of sediments. Okay, so when we have got a sea level that rises in an area, the water energy would decreases, allowing the deposition of fine-grained sediments in the same area. All right, so because now here initially this it was a beach, and then but when the energy of the sea changes, then we're gonna now deposit fine materials, such as the calcite. That's why we expect to see the limestone now being part of being be in the shallow seas, but now sandstone is now in the deep sea. That is example of the fascist analysis, a beach to sea, or deep sea transition. Okay, so this is by the guy called Johannes Walther, who says what can be seen laterally. So if we were to look this laterally, whatever that you see laterally can also be seen vertically. So we see this overlapping. We see this overlapping of calcite, overlapping the mud stones, and the mud stones will be overlapping also the sandstone. And then this lateral change can also be seen vertically. That's what we call the Walther's law of fascists. That what can be seen lateral can also be seen vertically. Okay, but now let's combine everything together. That is to say, fascists codes, the analysis, the and also the depositional environment. Okay, and depositional environment. So let's look at this one over here. So over here we see the massive mud stones and clay stones. Okay, these okay, this would this would be a massive mudstone, and then this one will be the clay stones, and somewhere over here we see a bit of laminations. Okay, so which is why the fascist name would be a massive mudstone. You can see it is massive. Here this part is very massive, even here it's massive. Okay, that's why we're saying this is a massive mudstone. And then somewhere here at the top we can say it's a bit laminated. can say it's a bit laminated, which is why also we can say laminated mudstone, but also a massive clay stones. Someone would also say it's a bit laminated. Okay, so when we say something is massive, we mean it is structural. It's a structureless. It means it does not have laminations. That's why we say some this is mudstone is massive. Then this one you can argue to say but we see a bit of lamination somewhere, so we can also say laminated clay stone. Okay, so if a mudstone is massive, okay, this would, the depositional environment would be the suspension settling in floodplain, lacustrine, or the marine settings. And then if it's laminated mudstone, it would be low energy deposition in overbank or floodplain or pro-delta environments. Okay. But over here, when we are looking at this core sample would represent a fine-grained, low-energy depositional environment, likely in a deep marine or lacustrine setting. So the fascist code FL, okay, which means the laminated mudstones or shale or mudstone or shale. This would suggest slow sediment accumulation with minimal disturbance, possibly in an anoxic environment, making it a potential source rock for hydrocarbons. So we've got also the well-preserved laminations, which indicate a lack of bioturbation, which may be due to low oxygen oxygen levels in the depositional basin. Okay. So, and then these core samples we see over here, we've got some dark colored, which are the dark colored. Okay, and then these are fine grained textured with distinct distinct parallel to wavy lamination. Somewhere they are parallel and then somewhere they are a bit wavy. Okay, the smooth texture and absence of coarse particles indicate a deposition in a low energy setting. So this would be the code, and then this this would be the code, and then this would be the by looking at these core, we have to also suggest the possible environment of deposition by looking at the texture, by looking at the color and other things. Okay. All right. Then over here, we see the massive bedded sandstone fascists over here. Massive bedded sandstone fascists. So this outcrop consists of the massive to bedded sandstone, and we've got SS. Okay, and then which is interbedded with a laminated shale. We see laminated shale over here. We see laminated shale over here. Okay, we see the laminated shale over here. Okay, you can see this is a shale and it's a bit laminated. Okay, and then this would indicate a fluctuating energy depositional system. Okay, the sandstone fascists suggest high energy conditions such as the fluvial or shallow marine settings, but the shale fascists would point to low energy deeper water environments. This combination would basically indicate to us a transgressive regressive cycle where sediment deposition varied due to shifts in sea level, tectonic activity, or a bit of climate fluctuations. Okay, so basically that is that, and the laminated shale is SH. Okay. So the rock appears as thick bedded sandstone with visible fractures and weathered surfaces. The bedding is inclined, suggesting tectonic deformation. You can see the bedding is a bit inclined, which would suggest a tectonic deformation. Okay, shaping the layering of these rocks. Okay, probably initially maybe they were horizontal, but now after tectonic deformation they were a bit like that. Okay. So you basically tell a story about what you see. Okay, you see this is we see visible fractures over here, and the surface is weathered, highly weathered. Look here. So we see extensive weathering over here, and then here we see massive, and then somewhere here we see some, some of these things that they are bit bedded. They're bit bedded, and then here we see this shale, dark, a bit dark, and we see these laminations. Okay. All right, and then over here we see these outcrop, which represent a dynamic depositional environment that is influenced by fluctuating flow energy. Okay, this is basically what you call the cross-bedded sandstone fascists, which would suggest the sediment transport in a fluvial or shallow marine system, likely within the migrating channel bars or maybe deltaic distributary channels. Okay, so these are, this is the what you call the ripple laminated sandstone, which indicates episodic shifts to lower energy conditions, possibly due to changes in water flow velocity or seasonal flood variations. This fascist association would suggest obviously an overall transitional environment, such as a delta front, or maybe we can think of something like a river channel, or we can think of tidal influence setting. Okay, so we can see these cross-bedded. Okay, so fascist code would be the planar cross-bedded SP, and then planar cross-bedded sandstone. Okay, and then or a ripple laminated sandstone. Okay, so the presence of distinct inclined laminae suggests cross-bedding formed by migrating sand dunes or bars in a unidirectional flow. The fine wave lamination suggests the presence of ripples formed by lower flow regime conditions. Okay, so we can see different things over here, and then something here, and then other things are going that way. So basically that is that. Okay, okay. So over here we see laminated or cross laminated sandstone. Okay, SH. All right. The rock exhibits thin, fine scale laminations. You can see these laminations are very, fine scale, which indicate them, which are indicative of sediment deposition under low energy conditions, such as distant fluvial or shallow marine settings. Okay, and then we also have got the visible. You see these, visible grayish materials. Okay. Which suggest a lithified sandstone or siltstone, okay, potentially containing clay materials, which where we see this grayish coloration. Okay, this fascist could represent a deposition in a fluvial overbank, okay, or deltaic or shallow marine setting where fine sand and silt were laid down under fluctuating current conditions. Okay. Now, in conclusion, the sedimentary fascists, codes, and fascist analysis are powerful tools that help geologists cover Earth past, like flipping through the pages of the history book. We know the history book has got important information. It tells us about what happened back in the days, and then it's like you are paging that book and you want to understand basically what happened back in the days when you were not there. Okay, fascists would tell us where sediments were deposited, whether in a roaring river, a silent deep sea, or a scorching desert. Now, fascist code would give us a structured way to classify and communicate these environments, making it easier to interpret geological records worldwide. We want someone in South Africa or someone in America to have the common understanding of the interpretation of sedimentary rocks. And then fascist analysis would allow us to reconstruct past climates, track ancient shorelines, and even find valuable resources like oil, gas, and the groundwater. So by piecing together fascists, geologists decode Earth past, and then they will be able to predict the future changes and even guide industries that rely on natural resources. So Next time, when you see a rock, remember it's not just a rock, it's a chapter in Earth's grand story. All right. So thank you, good people, for joining us today. We really appreciate your support. Please let us know what other sedimentary aspects we can cover in our next sessions. Okay. Thank you guys for everything. If you haven't yet visited our channel, or if you haven't yet subscribed, you are more than welcome to subscribe. But above all, please do not forget to hit the notification button below so that you get notified once we upload new content. And I always like to say, until next time, cheers.